So, have you ever experienced this incredibly frustrating yet kind of universal moment? You go to send a specific amount of crypto from your wallet to a friend, or maybe to another platform. You carefully type in the exact amount, you double check the address, you click send, and you wait. But when the transaction finally completes, you look and you realize the recipient got slightly less than what you originally sent. It's like some tiny fraction of a token just vanished into thin air along the way. If you've ever found yourself staring at your screen wondering what just happened, you are in exactly the right place. Welcome to today's Explainer, where we are going to solve the missing crypto mystery once and for all, and break down exactly how blockchain network fees actually work. Okay, let's dive into this. On our agenda today, we've got the missing crypto mystery, why blockchains charge, digital highways and gas, spotting different fees, and finally, how to reduce your costs. We're going to untangle this whole complex web, block by block. Section 1. The missing crypto mystery. Where did it go? Right, so you click send and your balance dropped by more than the amount you actually transferred. Where exactly did that crypto go? Well, the very first thing to understand is that the true culprit behind this missing balance is usually not the creator of the cryptocurrency itself. And honestly, it's almost never your specific wallet software trying to just skim a little off the top. Instead, the deduction you're seeing is directly tied to the underlying blockchain network. And that brings us to a really fundamental definition, a network fee. This is simply a fee associated with processing a transaction on a blockchain network. You see, when you send crypto, you aren't just pinging a digital message directly to a friend. Your transaction actually needs to be independently verified, processed, and then permanently recorded on the blockchain by a huge decentralized network of computers. This fee, it's essentially the toll required to get your transaction verified and etched into that digital ledger. You might also hear folks call it a transaction fee or a blockchain fee, but trust me, it all means the exact same thing. Moving on to Section 2. Why blockchains charge. 4 key purposes. Now, I know what you're thinking. These fees can feel like arbitrary charges just designed to annoy you. But network fees actually serve 4 absolutely critical purposes that keep these networks alive. First up, processing transactions. Blockchain networks need participants to do the heavy lifting of processing transfers, and fees provide an economic incentive for the people or organizations operating that infrastructure. Second, preventing spam. Think about it. Without fees, someone could just send millions of meaningless transactions to clog the whole system. Fees make large-scale spam incredibly expensive, which protects the network. Third, supporting network security. These fees often contribute to the rewards that miners or validators get, literally the people keeping the blockchain secure. And fourth, managing limited block space. Blockchains can only process so much data at a time, so when demand spikes, fees act as a sort of bidding system to manage that limited space. Section 3. Digital highways and gas. Network congestion. To really visualize how this limited space works, it helps to think of a blockchain as a digital highway. When there are only a few cars out on the road, traffic moves perfectly smoothly, and the toll is cheap. But what happens when thousands of cars try to merge onto that exact same highway at the exact same time? Complete congestion. In the crypto world, this usually happens during major market events, massive token launches, or just sudden spikes in trading. When thousands of users submit transactions all at once, competition for that limited block space just skyrockets. And on networks with dynamic fee markets, you suddenly have to pay a much higher toll if you want your car, meaning your transaction, prioritized and pushed through that massive traffic jam. Now, what's really fascinating is how the 2 biggest networks handle their tolls completely differently. Let's compare Bitcoin and Ethereum. On the Bitcoin network, fees are generally influenced by the physical data size of your transaction and the current demand for block space. This means sending 0.01 Bitcoin doesn't automatically mean you pay a lower fee than sending 1 full Bitcoin. It's entirely about the transaction's data structure, not the monetary value. Ethereum, on the other hand, well, it operates differently. Its fees are based on the actual computational work required to process your specific action. And this brilliantly illustrates the concept of gas. Gas is a unit used to measure computational work on networks like Ethereum. Think of gas as the amount of engine power you need to perform an action. A simple transfer of Ethereum from one wallet to another, that's like driving a tiny, efficient, compact car down the highway. It takes very little gas. But interacting with a complex, decentralized finance application, swapping tokens, or minting an NFT, that is like driving a massive, heavy-duty 18-wheeler down that same highway. It requires a lot more computational work, meaning it requires a lot more gas, which ultimately results in a much higher total network fee. Section 4.
spotting different fees, network versus exchange, getting tripped up.
Okay, this is an area where so many users get tripped up, so we need to be really clear here. It is incredibly important to draw a hard line between a network fee and an exchange fee. Let's say you log into a popular crypto exchange and buy some Bitcoin. The exchange is going to charge you a trading fee. That is an exchange fee. It's a service charge paid directly to that company for facilitating your trade. But if you then decide to withdraw that Bitcoin off the exchange and send it over to your own personal hardware wallet, a separate blockchain-level transaction happens. And that triggers a network fee, which goes to the miners or validators, not the exchange. You're also going to see fees pop up inside your own personal wallet software. Before you approve a transaction, your wallet will usually display an estimated network fee. A massive point of confusion for beginners is thinking the wallet provider is just pocketing this money. In reality, cryptocurrency wallets generally just provide the interface. They are simply analyzing the network's current traffic and estimating the blockchain's required toll on your behalf. The fee is going to the blockchain network itself, not the creator of your wallet. They're just the messenger. And this leads us to a uniquely frustrating situation, beautifully captured in this quote from our source material. Holding a token on a particular blockchain does not necessarily mean that token itself is used to pay the network fee. Imagine driving onto a toll road with a physical wallet absolutely stuffed full of gift cards, but no actual cash. You're completely stuck, right? In crypto, a blockchain usually requires its own native asset to pay the fee. So if you're sending some random token on the Ethereum network, you cannot pay the fee using that random token. You absolutely must have actual Ethereum in your wallet to pay the gas. If you don't, your transaction is just sitting there, stuck at the toll booth. All right. Final section, Section 5, How to Reduce Costs. Keep fees low. So the crucial point is, how do we navigate this efficiently? Well, you actually have the power to manage these costs if you play it smart. Here is your quick checklist. Number 1, always check the estimated fees first. If you're sending a small balance like $10 and the network fee is $5, that transfer just isn't practical. Number 2, wait out network congestion. If fees are astronomically high, just wait. Traffic jams clear up, usually overnight or on weekends, and those fees will naturally drop. Number 3, compare networks. If a platform allows you to use a lower-cost blockchain, or maybe a Layer 2 network, take advantage of it. Just be absolutely sure the receiving wallet supports that exact network. And number 4, avoid unnecessary transfers. Try to consolidate your moves. Every single time you touch the blockchain, it costs money. Now remember, you can sometimes choose a lower fee manually in your wallet settings, but be warned, choosing a cheaper toll might mean your transaction gets stuck in the slow lane for quite a while. And that brings us to our final thought for today's explainer. You wouldn't merge onto a toll road in the real world without checking the price on the sign first, right? So why on earth would you do it with your crypto? Network fees are a completely normal, healthy part of interacting with decentralized blockchains. They secure the network and they incentivize the participants. But by simply taking 3 seconds to check the network conditions, verifying your destination address, and making sure you actually have the right native asset to pay the toll, you take complete control of your digital journey. Thanks for joining me on this deep dive into blockchain network fees, and until next time, keep exploring and keep learning.